you may be wondering about where these file permissions came from. So the answer is umask. So the umask command sets the default permissions for any file or directory you create. So for example, touch my new file, and here we're gonna see here lsal and new file here. Oops, not my new file. So here, as you can see here, the touch command created the file using the default permissions assigned to my user account. As you can see here, that's it. The umask command sets the default permission. So unfortunately, the umask command setting isn't overtly clear. So, and trying to understand exactly how it works make things even muddier and hard to understand. So the first digit represents a special security feature assigned to a file, umask here. As you can see, in my case, it's 022. And probably you will have that number too, or 022 or 00222. So we will talk more about that later in this course. And let's get started with understanding our file permissions. So the next 3 digits represents the octal values of the umask for a file or directory. So to understand how umask works, you first need to understand the octal mod security settings. So octal mod security settings take the 3 RAAX permission values and convert them into a 3-bit binary value represented by a single octet value in this permission here. So in the binary representation, each position is a binary bit. So if the read permission is the only permission set, the value is going to R minus R null here. So relating to the binary value of 1, 0, 0. So indicating the octal value 4. That's it. And you will learn all of this in this lecture. So let's get started with our representation of file permission codes in Linux. So permissions, firstly we're gonna write it permissions, binary, and here we're gonna have octal, and lastly the description. And here in permission, for example, if we don't have a permission here, then in binary we're gonna have 0, 0, 0, and in octal we will also have 0, and description is gonna be no permission. So actually I will share this file after completing it. So you will need this file after some time in assigning the permissions in files or folders. So this has no permissions at all. So permissions here, and we will also have the null x here, which is going to be 0, 0, 1 and 1, and it's going to be, as you remember in previous lecture, what's going to be? It's going to be executable, and here execute only permission. And we can also have the write only permission here. You have learned this in previous lectures. So 0, 1, 0, and it's going to be 2, and it's going to be write only permission. And here we will also have 0x. Guess what it is? 0, 1, 1, and it's going to be 3, which, remember, yeah, it's going to be write and execute permission. And here we also have R minus, and it's going to be, guess what, 100. And here we're going to have 4, and as the name implies, and you learned in previous lecture, it's going to be read only permission. We can also have Rx, which is going to be 1. Guess what? 0, 1. And here we're going to have octal 5, and it's going to be read and execute. And here we will have, what will that? R and W. And guess what it is? Here 1, 1, 0, and here we have octal number of 6. and it's going to be, guess what? The read and write. Read and write permission. And lastly, RWX, which is going to be 1, 1, 1, and 7, which is going to be, this will have all the permissions it has. So read, write, and execute permission. So octal mode takes the octal permissions and lists 3 of them in order for the 3 security levels: user, group, and everyone. So use the octal mode value here represents 6, 6, 9, 664, which is represents the read and write permissions for the user. Actually, let me write that nicer here. So in this case, 6, 6, and 4. So the 6 here, remember, the 6 here represents read and write permissions for the user. So as you remember in previous lectures, the first is user, group, and everyone else. So here the 6 for user, and it's going to be read and write permissions to user, and for the group, this is the same for the group here. So same for the group. The group also has the read and write permissions, and the 4 is everyone else, which is everyone else can only read this file and do not write, delete, or execute it. So that's it. So now that you know about the octal mode permissions, the umask value becomes even more confusing. So the octal mode here, actually, let me write that down here. Yeah, the octal mode shown for the default umask on my Linux system is 022. In your system it might be 0022, so it's all the same actually. So but the file I created, I had an octal permission of 644. So how did that happen? So here actually LSLA. So oops, let's clear. By meaning that 644, I just want to show you here. So let's actually copy this. Yeah, and here, as you can see here, this means our file is file, the regular file. And here, let's actually make it a bit look nicer. We don't need this information now. And here, so let's turn this into binary and octal number. So turning this into binary and octal number. So here it's going to be 0. Actually, we don't need that either. See, this is just a file representation that it's file or symbolic length. So you learned that. Actually, you learned that in previous lecture. If you don't remember, just go back to previous lecture and come back here later. So here, RW, remember, RW6, right? 6. Actually, yeah, 6. R null is going to be 4 and 4 here. And here we would also have, in the binary representation, is going to be RW is going to be 110, 1 here, 110, 10, and 10 here. That's it, right? It's actually not that complicated, right? So, but here 0 to 2, here you will understand all of this here. So the umask value is just the mask. So it masks out the permissions you don't want to give to the security level. So now we have to dive into some octal arithmetic to figure out the rest of the story. So the umask value is subtracted from the full permission set from an object. So the full permission here is 7, 7, right? So the full permission is 777, right? Actually, let's yeah, we can also use this arrow to look it nicer like this. And here That's it. It looked nicer, right? So the full permission is 777, right? So, and actually, and read and write permission, we also have the full permission. I say it's kind of full permission here, but 666 is the read write permission for all. But for directories is 777, which is read, write, and execute permission for all. To use in this example, the file starts out with a permission 666. The starts with 666, which is read and write permissions for all. Read and write permissions for all. So let's actually mention that down here. 666. So which is read and write permissions for all. But for directories, it's 777. Starts file. For file, it's 666. And for directories, starts with directories, it's what I said, the 777. Here, that's it. So, to use in this example, the file starts out, so as you remember, we created a file, right? My new file. So the file starts with a 666 and the umask 022 is applied. So leaving a permission 644. So you will now understand all of this. So 666, right? This starts with the file. And if we apply 022, we need to subtract that 022 from 666, and it's going to be what? The 644. And that's all the logic with our umask file. And here, as you can see, 644. And we can also do, for example, let's change our umask file. For example, umask 026. And here, you can also actually, the umask value is normally set in the etc profile, cat etc profile, and oops, cat here. I will just read here, and as you can see here, the umask value is usually set in the etc profile startup file here. And you will learn about this file in later lectures. You can specify the different default umask settings using the umask command. So for example, umask 026, and let's check the umask now. Umask and touch new file 2 ls, and here here lsla my file, my file, new file 2, and here, as you can see, let's actually copy that down here and see what changed. It's actually something changed, right? Right here. Let's copy this, paste it here. So in this case, actually, let's actually mention it that our default def here, your mask when we executed this command and created this file, our mask was 022, right? As you remember. And here, so our w1 2 3 and 1 2 3. Here. So in this case, when we created this file, our umask number was what was it? 026. And you will now understand it more deeper here. So RW, what was it? 6, right? So 6 is 110, and then R minus. Our null is 4, right? 1 0 0, and lastly we have no permission at all, and here it will have what? 0 0 0. And in this case, our default file permission is going to be what? Yeah, I'm waiting for you. 3, 2, 1. It's gonna be 110.6 100.4 and 0 and 0. That's it. That's as easy as that. So now let's actually so this examples was all executed on a files, and let's try with the directories here, right? As you remember, files and directories default permission, the full permission is different. So file is 666 and for directory is 777. So when we set the umask value to 026, the default file permissions become 640. This is for file. So the new file is now restricted to read only for the group members, and everyone else on the system has no permissions to the file. So the umask command also applies for making new directories here. So umask make dir, oops, not umask here, clear. So make dir my new directory, or my new dir, it's okay, and ls l my new dir, oops, ls l la here. Don't we have my new directory here? Oops, sorry. My new file, my dir, my new. Yeah, as you can see, this is our my dir, and let's copy that out and see what actually happened here for dirs or examples. Here, so let's so this d here, I will explain all of this right now. So this here, d here, as you remember in previous lectures, this d means that it's a directory, so we don't need that. We already know that it's the directory. So rwx, remember 7, right? So mask was for 026. Again, let's check the mask. Clear, umask, and that's it's a 026 here, 026, and the mask is going to be 026 here, as you can see here, the 026, and it's gonna, so rw6 rwx is going to be 7, which is 111, then rx 101 and 00x here, just the 1, so 001. And let's turn that into octal. 111 is 7, 5 and 0. Here, that's it. As you can see here, because a default permission for a, and this, as you can see, these are the complete different numbers, right? And you will understand now. So because the default permissions for a directory are 777 and the resulting permission from the umask are different from the use of a new file, the 026 umask value is subtracted from the 777, leaving the 7. Actually, it was not 1 here, so sorry for that. It's 1. So the directory permission setting here. Actually, let's prove that. So here, now we're gonna 777, and after that we're gonna enter 026, and here we would have 7, 5 and 1. It's proven.